video, I'll be introducing standing waves. Let's begin with the simulation of a string that is fixed at two ends. I'm going to send a single pulsed wave along the string and we'll watch as it reflects off the opposite end. Now watch what happens if I send a second pulse along the wave sometime after the first. When the two waves meet, they superpose. At some points they will interfere constructively and at other points they will interfere destructively. This is perhaps best illustrated by sending a progressive wave along our string and watching it reflect off the end. Note that when it does reflect off the end, the two waves, one travelling to the left and one travelling to the right, superpose such that certain points along the wave are stationary, they're not moving up or down. We can call these points nodes. At other points along the wave, we have our maximum displacement. These points we will call antinodes. We should note that if this is one full wavelength, then each adjacent pair of nodes is exactly one half wavelength apart.
Okay, based on the previous video, we know that standing wave or stationary wave is defined as a form of a wave whose profile do not move and no energy is transferred from one end of the medium to the other end. Okay, and then the stationary wave is formed when two waves with the same speed, frequency and amplitude which are travelling in opposite direction are superimposed. Kalau you tengok tadi video, dia akan gerakkan satu wave kan, and then sampai dekat hujung clamp tu, dia akan reflect balik with the different phase. Maksud saya opposite direction. Okay, so macam ni lah tadi dia dah gerak first dengan direction macam ni. Once dia sampai at the end of this, dia akan balas balik with the opposite direction of progressive wave. Ni kita panggil progressive wave. Progressive wave maksudnya macam mana nak hasilkan standing wave, dia mesti ada dua progressive wave yang mempunyai direction yang berbeza. Okay, satu direction adalah ke kanan dan satu lagi direction adalah ke kiri. So once dia dah gerak kanan dan kiri, dia akan superimpose, so dia akan jadi shape macam ni. Okay, so that's why you kalau you adalah aplikasi dalam kehidupan kita lah, when we plug the string of the guitar, so kita akan nampak vibrating macam ni. You akan nampak atas dan bawah kan, vibrating mood dia. Tu kita panggil standing wave lah. Okay, by considering the wave function for two progressive wave, kita ada nampak akan ada dua equation progressive wave. Satu adalah negative and satu lagi adalah positive. Why? Because direction of the wave is opposite to each other. Kalau negative means that wave propagates to the right. Kalau positive, wave propagate to the left. Okay, so by applying the principle of superposition, so ni adalah equation ni lah. Finally dia come out dengan equation ni. Ini just macam pengenalan sahaja. Okay. Okay, this is experiment 6, standing wave. Okay, learning outcome at the end of this lesson, students should be able to investigate standing waveform in a stretched string and then to determine the mass per unit length of the string. Okay, so based on the theory, they use equation F is equal to 1 over 2L set T over mu. Kenapa dia guna equation ni? Sebab equation standing wave ni ada dua type. Satu adalah string and satu lagi adalah closed pipe. Adalah pipe. Dalam pipe ni ada dua pula, closed pipe dengan open end. Korang tak belajar lagi, jadi macam tak nampak benda ni. So untuk eksperimen ni dia buat untuk string. Dan kenapa dia ambil equation ni? Sebab ini adalah equation untuk fundamental, means that satu apa panggil? First overtone. Step yang pertama lah, maksudnya tone yang pertama, bunyi tone yang pertama dia akan ambil. So that's why formula dia guna 1 over 2L set T over mu. Kalau second overtone dia akan jadi formula lain. Okay, sebab tu bila eksperimen ni you hanya ambil untuk two consecutive notes. Maksudnya notes kepada notes, jarak dia berapa. Ini yang kamu nak cari. Sebab tu kita guna formula ni, because dia nak untuk two consecutive notes, iaitu sama dengan first fundamental lah. Fundamental ataupun kita panggil dia adalah first overtone. Saya selalu buat first OT je, first overtone. So yang ni you akan belajar dalam chapter 10. Okay, so as you know that F is adalah frequency, L adalah length between two notes, T adalah tension in the string and mu adalah mass per unit length. So kita punya aim hari ni adalah untuk cari what is mu, mass per unit length, mu. Okay. So based on equation, so kita tahu kita akan plot graph T against L square. T against L square. So bila T against L square, so based on this equation, okay, we arrange equation as T sebagai subject. So we get T is equal to 4 mu F power of 2 L power of 2. So bila kita buat T against L squared, means that T is component Y and L squared is component X, means that X axis of the graph. So the gradient come out as 4 mu F power of 2. Okay, so value of mu can be calculated. Okay, so this is apparatus that we use. Okay, we have a wooden wedge. Okay, ni benda barulah. Okay, so this is a procedure, the setup of apparatus. Okay, what you can see here, we have a metal rod, soft iron and magnet bar. Actually connect to AC supply. Why? Because kita nak hasilkan vibrating wire. Okay, benda ni akan vibrate. This akan vibrate magnet kan, akan vibrate untuk hasilkan wave lah. Okay, so wooden wedge ni untuk apa? Untuk ukur kita punya first notes, two notes. Okay, so nanti you akan letaklah wooden wedge ni untuk adjust supaya you dapat shape note yang pertama. Shape note yang pertama dia macam ni. Bila kita ubah mass, kita punya link strength of stretch of wire ni akan semakin berubah lah. Kalau mass semakin berat, stretch of wire ni semakin tinggi. Maksudnya bila semakin berat, mass semakin tinggi, so kamu punya shape ni akan lagi besar. Sebab wire tu terlalu tegang. Tapi bila mass kita, ni mass kalau tinggi lah, kalau mass kita rendah, so kamu punya ni mungkin ada banyak lah. Tapi yang kamu nak ukur hanya satu saja. Okay, alright, macam itulah panjang yang sama. Okay, contoh. Alright, so next, okay, set up apparatus. Okay, kita connect terminal solenoid with AC power supply to have a vibrating wire. Okay, do not exceed 4 volt to avoid damage of the solenoid. Okay, place metal rod between two bar magnets. Okay, tak apalah ini. Okay, tie one end of the string and to the rod and the other to the hook of the slotted mass. Make sure that the length of the string from the end of the rod of the pulley is not less than 1.5. Kena panjang 1.5 lah. Sebab dia nak panjang. Kalau tak nanti wave awak tak boleh nak baca. Mungkin nanti sekejap lagi bila mass you terlalu berat ke apa, tiba-tiba tak boleh nak cari length dia sebab panjang sangat. Tak cukup. Okay. And then switch on the power supply, adjust the position of metal rod to get the maximum vibration. Dia nak jadi vibration tu tinggi lah. Okay. Kemudian dia kata adjust the position of the wooden wedge until a clear single loop standing wave ataupun kita panggil fundamental mode ataupun first overtone is observed. Record the distance L between the wedge and the total mass M of the hook and the slotted mass. Okay, so kamu kena tambah mass lah sampai you dapat shape of the first, iaitu fundamental mode with the consecutive notes to notes, different L lah, with changing of masses. Masses bertambah, masses berkurang, berapa nilai L dia. Okay, so dia prefer dekat sini, dia kata kena start dengan small mass lah. Okay, and then repeat step at least 6 different readings. 6 different reading means that 6 bacaan lah. Okay, so construct a table for the value of M and L. So calculate the weight when weight is equal to mg. Kenapa weight sama dengan mg? Dia kata note that weight is equal to T and Y. Kena explain lah. Okay, kenapa weight sama dengan T? Based on equation yang you belajar sebelum ni. As you know that slotted mass kita ada weight, and then ni adalah string, kita ada tension, but the case is stationary, so means that no motion. Jadi kat sini you dah tahu summation Fy is equal to 0, so T is equal to W lah. So T sama dengan mg, means that directly. But remember that the mass must be changed in SI unit lah, dalam kg. Okay, kemudian plot graph T against L square. Okay, and then determine the gradient of the straight line graph. As you know, tadi kita dah buat kan, dia dapat T is equal to 4 mu F power of 2 L power of 2, and then compare equation with Y and X axis of the graph, and then here we come out as gradient. Okay. Okay, then deduce the mass per unit length, iaitu mu yang dia nak cari is uncertainty of the string if the frequency of the vibration is 50 Hz. So gantikan F ni sebagai 50 Hz. Okay, dia dah bagi. Then you akan dapat nilai mu. And then uncertainty pun you boleh cari. So means that jawapan you mesti dalam bentuk macam ni lah. Mu plus minus delta mu. Dan unitnya adalah because mass per unit length. So should be kg m negative 1. Is it? Mass per unit length. Okay, so mesti mass tukar dalam kg.